Yeah, we are going to discuss about electric dipole. Okay, let's try to understand what is the electric dipole. Okay, basically all of the charges founded in nature are monopole. Okay, I mean charges have only single pole, like either it is positive or negative. Are you clear? But when we assemble two opposite nature of charges of same magnitude, then they constitute a dipole. Okay, what is the means here? The assembling of two equal the assembling of two equal the assembling of two equal assembling of two equal and opposite charge one second. Separated at a separated by a small distance the small distance constitutes electric dipole. Okay, constitute electric dipole. Some are you clear or not? What does it mean? It means that when two equal and opposite charges of same magnitude are separated, or you can say are kept at very small separation, then this formation is said to be the dipole. Okay, because now in this system there are two opposite nature of charges are available, which is the first one of the charge is plus q and the second one is the minus q, and we are taking the separation between them is 2L. Are you clear or not? Just similarly, you have already know about the magnets. What are the magnets? Magnets also known as a dipole because they have north pole and south pole. Okay, N and S. In magnet, both of two poles are found. So magnet is also a dipole. Are you clear or not? All of you are understanding or not?
Yes.
Okay. Some monopoles are like monopole like electron, proton, and so on. Just similarly, what will be the dipole? Some dipoles are HCl. You have already know the structure of HCl like this. HCl. The another one is NaCl. NaCl. In NaCl, you can see here that there is also two poles are found. The first one, Na. Na is of positive and the another pole is chlorine, which is negative. Okay. It is also constitutes dipole. Just similarly, the another last one is the magnet. The third one is the magnet, because magnets also constitutes dipole. Magnets also constitutes dipole. Like this is your north and this one is your south. Okay. And so on. Note it down, please. Note it down, please. All of you have noted it?
Yes, sir.
Can we move on?
Yes.
Hello?
Yes, sir. Move on.
Okay. Now, the next heading is electric dipole moment. The next heading is electric dipole moment. Okay. Electric dipole moment measures strength of the dipole. What is the role of the electric dipole moment? It measures strength of dipole. It measures strength of dipole. Okay. What is the unit of dipole moment? Sorry, what is the formula? The formula is P is equal to Q into 2L. Okay. P is equal to Q into 2L. This is the formula of electric dipole moment. Unit, you have already know the unit of charge is coulomb and 2L. L is the length. What is the length? Length is the separation between these two dipoles. These are the dipoles. And the separation between them is 2L. You can draw this again. This is your plus Q. This one is the minus Q. The direction of the electric dipole is always from negative to positive charge. Remember, always. And the separation between them is we are taking 2L. Okay. What is the reason behind taking the 2L? Okay, we will discuss in the next point. All right. I mean, in the next heading. What is the SI unit? The SI unit of electric dipole moment is coulomb meter, and it is a vector quantity. Which type of quantity? It is a vector quantity. And the last point, what is the direction of the electric dipole moment? The direction of electric dipole moment is always from minus Q charge to the plus Q charge. Okay. Note it down fast. Note it down, please. And now we have a question which is, note it down. The question is, two charges plus minus 2 microcoulomb are placed at 0, 0, 2 and 0, 0, minus of 2 mm. Calculate dipole moment of the system. Calculate dipole moment of the system. Okay. This is the question based on the electric dipole moment. Okay. Now you can see in this question that the magnitude of the both charges are the magnitude of charges are plus 2 microcoulomb and minus 2 microcoulomb. Okay. First of all, we are going to draw it. This is your plus 2 and this one is your minus 2. Separation between them are also given as 0, 0. Just 1 second. Yeah. The position of the charges are given as like 0, 0, 2. This is your value of x. Like you can see here, position is given as 0, 0, 2 and the second pole is given at 0, 0, minus 2. Okay. This is your x, y and z coordinate, right? Then how can we draw it? Look at here. This is your coordinate of x and this one is the plus of y. All right. And the third coordinate will be in this direction. Okay. Then the position of first charge, I mean plus q, is at z axis. When you draw this line along there, this is the position of the charge, which is your plus of 2 microcoulomb. Okay. And another charge is placed at this position. This is your minus of 2 microcoulomb. The position of this one is 0, 0, 2 and this is your 0, 0, minus 2. Okay. What is the separation between them? The separation between them is 4 mm, which is given in your question. Just 1 second, it is given or not? No. Also mention here a meter. Yeah, no issue. Look at here. This is your y axis of plus 2. Okay. I mean, this length is of, 1 second, this length is of your +2, and this is your also +2. So the separation between the both charges will be 4 mm. Are you clear? Note it down first,
Yes.
then we will solve it. X-axis, Y-axis, and Z-axis. The value of charges which is given as Q is equal to 2 microcoulomb, which is equal to 2 into 10 raised to the power minus of 6 coulomb, and the separation between both charges, which is 2L, is equal to the 4 mm. Which are 4 into 10 raised to the power minus of 3 meter. Then what will be the value of the dipole moment? The dipole moment will be P is equal to Q into 2L. 1 second, it is not 4 mm. Yeah, 4 mm. Okay. What is the value of Q? It is 2 into 10 raised to the power minus 6 into value of 2L is 4 into 10 raised to the power minus of 3. Okay. After calculating 4 into 2, you got 8 into 10 raised to the power minus 6 and 10 raised to the power minus 3 will be 10 raised to the power minus of 9 coulomb meter. Are you clear? Note it down, please. I think, and what will be the direction? The direction is always from negative to positive charge. This is the direction of this dipole moment. Okay. So you can look at here. This is your plus K axis and this is your minus of K axis. So we can also write the vector of P is equal to 8 into 10 raised to the power minus 9 minus of K. I mean in the direction of minus of K coulomb meter. Okay. Note it down, please. Note it down, please. All of you are clear or not?
Yes.
Okay. Note it down fast.
Why do we take 2L, sir?
Sorry.
Why do we take 2L?
Yeah. The reason behind the 2L. Okay. We will discuss in the next heading. Are you clear?
Okay, sir. Okay, sir. Okay,
Yeah. Note it down fast, please. Can we move on?
Yes, sir.
Okay.
Sir.
Now, the next question. Calculate dipole moment of system. Calculate dipole moment of system. Okay. The system are like this. This is your a triangular system at the vertices of which at the two okay, at the two vertices, two positive charges are given, plus Q and plus Q. At one of its vertices, a charge of minus 2Q is given. Separation between all of the vertices is L because it is a equilateral triangle. Okay. Now it is saying that calculate dipole moment of system. Note it down. Now, let's try to understand how can we solve it. Okay. You can see on the vertices of A. You can take it as A, B, and C. At the vertices A, the magnitude of charge is minus of 2Q. All right. The magnitude of charge is minus of 2Q. In this way, okay, so we are going to separate minus Q and minus Q separately. Okay, we are treating this minus 2Q charge as minus Q and minus Q, okay, separately. Are you clear or not? Okay. Why? Because the condition of the dipole is a dipole constitutes when two equal and opposite charges are, okay, separated at a very small separation. Like if the first one of the charge is minus of 2Q, then the another should be plus of 2Q. If you are taking the minus of 5Q, then the another charge should be plus of 5Q. Okay, then it will be dipole. And if you are taking minus of 5Q and the another one is plus of 2Q, then it never constitute a dipole. Okay, these two constitutes dipole. Are you clear or not? Causing which we are going to consider here minus 2Q charge as minus Q and minus Q separately. Are you clear? Then for the first charge, the direction of the charge, the direction of the dipole will be along this direction. Along this direction, okay, you can take it the dipole of first, and the another will be in this direction. Okay, you can write here, this is your of dipole of first P1, and this one is the dipole of P2. Are you clear? Now you are seeing here there are the two dipoles are acting at the same point at some particular angle 60 degree. In this case, what will be the resultant direction of the dipole? Then the resultant direction of the dipole will be along the diagonal of these two. Okay, this gives you the resultant dipole moment. This is your P net. And now we have already know the value of P1 is Q into 2L, but the separation between them are given as L. So we are taking L. And the another one P2 is Q into L. Now what will be the resultant? The angle between theta between P1 and P2 is 60 degree. Okay. Then what will be the resultant dipole? The resultant dipole will be P net is equal to P1 square P2 square plus 2P1 P2 cos 60 degree under root. What is the P1? P1 is Q into L square plus Q into L square plus 2 into QL. P2 is also QL cos 60. Cos 60 is 1 over 2 under root. This will be Q square L square plus Q square L square plus 2Q square L square into 1 over 2. 2 is cancelled with 2. Finally, you got Q over L square 3 times. Okay. We can write here 3 Q square L square. Okay. And we can also write 3 P, because you can look at here P1 and P2 are same in magnitude, and we can finally consider as P. This is your root of P, which is root of P root of 3, and it is, what is the value of P? It is QL root of 3. This is your final answer. Okay, note it down fast. Note it down, please. All of you noted it?
Wait.
Yes, sir.
Hello?
Yes, sir. One second.
Okay, okay. It's over, Matthew.
Yes, sir.
Okay. And now the another question is, calculate dipole moment of the system. Calculate dipole moment of the system. And the system is like this. This is the given system. The charges are present at its vertices. Like this. Okay. This is your minus of Q and this one is your plus Q charge. This separation is A and this separation is also A from O. Okay. It is saying that calculate dipole moment of the system. Anyone can solve it or not? Matthew, Zarsh, Nawal, any one of you can solve it? Hello?
Yes, sir. We have to take the root right.
Please try to solve. You can understand here like if these two sides are A and A, then according to the Pythagorean theorem, the diagonal will be A root 2. Are you clear? This diagonal will be A root 2. Am I right or not? Are you understand it?
Yes, sir.
This is the diagonal, I mean the separation, or you can also say displacement between these two charged particles, which is equal to the 2L. So we have already know the electric dipole moment. The electric dipole moment will be P is equal to Q into 2L, which is equal to Q into, what is the value of 2L? 2L is A root 2. Okay. This is your final answer. Are you clear or not?
Clear, sir.
Okay, good. Okay. Till now, we have completely understand about the dipole and some basic questions. I mean, the concept also. Now, we are going to discuss about the field of the dipole. I mean, electric field of the dipole. Are you clear? What we are going to do now? We are going to understand about the electric dipole field. Are you clear?
Okay,
Now,
sir.
to understand the electric dipole field, one second, dipole field. Okay. Now, what is the dipole field? Dipole field is basically electric field of dipole. Okay. It is the electric field of dipole. Okay. In this heading, there are 3 types of problems are generated. Are you clear? Now, let's try to understand. Suppose that we have a dipole. We have a dipole like this. One second. We have a dipole. This is your one charge. This is your another charge. Okay. And both are separated at a finite separation like R, you can say also. All right. Then the point laying at the axis of the dipole. The point laying at the axis of the dipole, either right side or left side or any position, okay, is said to be the, this is your said to be the axial line. Okay. This is your axial line and the point on this axial line at any position is said to be the axial position. Are you clear? Are you clear or not?
Yeah.
The point laying on the axial line of the dipole is said to be the axial position. Okay. You can also say it like axis of dipole. Okay. This is your plus Q charge and and this one is your minus q charge. Separation between them is 2L. Okay. And now the point laying at perpendicular to the axial line. The point laying perpendicular to the axial line, like this. Suppose that you have another point which is laying at this position. Okay. Then if you draw a line, then you got a perpendicular on the axial line. Okay. Then this position is said to be the equatorial position. Equatorial position or equatorial point, this point. Okay. And this line is said to be the equatorial line. Are you clear or not? This line is said to be the equatorial line. Are you understand it? Remember that equatorial line always be perpendicular from axis of dipole, or you can say axial line. Okay. Are you understand or not?
Yes, sir.
Yeah. It always be perpendicular to the axial line. Okay. And now, if you are taking the another point, okay, instead of axial line and equatorial line, okay, any one of the position, like you can take at this position, this position, this position. Are you clear or not? But the condition is that that point should not be at axial and equatorial line. Are you clear? It always be at any another point. Are you clear? Like I am taking at this position. Okay. When you try to join this point from the center of the dipole, then this point is said to be the general point. Okay. This point is said to be the general point, and it make always angle theta from the axial line. Are you clear? It always make angle theta from the axial line. Okay. This theta neither be 0 nor 90 degree. Are you clear or not? For general point, it may be like 10 degree, 15, 30, okay, 50, 60, 70 or 80 degree or 85 degree. Are you clear? But it neither be 0 nor 90 degree from the center of the dipole. Are you understand it or not? Hello?
Yes, sir.
Yes.
Yeah, all of you are understanding or not?
Yes, sir. Yeah.
Okay, good. And now, on the behalf of this, we are going to study first the field due to the, the field on axial line. Our first point is field on axial line. Then we will study about the electric field of the dipole on equatorial line. Equatorial line. And the third one is field at general point. Okay. But it is in general, it is not in our syllabus. Okay. So we will study about these 2 points. Are you clear or not?
Yes, sir.
Note it down. Note it down fast. Sometimes it is asked about the general line, but it is not. Okay. It is not more important for you. Okay. Note it down fast, please. These two fields are very important. These two are very important. Okay. Note it down fast, please. Because today I want to cover minimum these two headings: field on axial line and the field on equatorial lines.
Done, sir.
Okay, all of you have done?
Yes, sir.
Okay, good. And now our next heading is electric field on axial line electric field on axial line of dipole at point P. At point P. This is your next heading. Okay. Electric field on axial line of dipole at point P. In this, first of all, let's draw the diagram of the electric dipole. This is your charge of minus Q, and this one is the plus Q charge. Okay, and we are going to calculate. One second. First of all, join these two with each other. Okay, first of all, we are going to calculate the electric field due to this dipole at the position of P. We are taking position P here. This is your position P. Are you clear? Now, then, first of all, join this point P from here. And now, it is also remember that the separation, or sorry, the distance measured from the dipole always be taken from the center of the dipole. Are you clear? The distance always be measured from the center of the dipole. Let's consider that the separation between the two charges are 1 second, just 1 second, give me 1 second. Okay. Yeah. The separation between these two charges are two A. We are taking as 2A. And this is the center of the dipole. Then what will be the separation of the point P from minus of Q charge? This is your minus Q, this is your plus Q charge. Okay. And the separation between 2A and P is R. This separation is R. Then what will be the separation between plus Q and P? It will be R minus A, and the separation from minus Q to the P is R plus A. Are you understanding or not? all of these separation?
Yes, sir.
All of you are understanding or not?
Yes, sir.
First of all, separation between the two charges are 2A. So you can also consider it, right? Like A, this part is A and this part is A. Okay. So the separation from the plus Q charge to the point P will be R minus A, and the separation from minus Q to the point P will be R plus A. Okay. Now, what will be the direction of electric field due to the plus Q charge at point P? Anyone? I think
1 by
it
4
will
pi
be away
epsilon
from the
naught.
charge. What will be
1
the
by 4
direction?
pi
I am asking, not in
epsilon naught
magnitude. It
r
will
naught.
be away from the charge, like E plus. Okay. Yani electric field due to the positive charge. And the electric field due to the negative charge will be in this direction. Am I right or not? Why? Because positive charge, sorry, the direction of the field due to the positive charge always be away from the charge. And the field due to negative charge will be towards the charge. Are you clear? So it is a field due to these two individual charges. Now, what will be the electric field at P, E at P due to plus Q charge? It is E plus is equal to, sorry, E plus Q is equal to K Q over. What is the separation between plus Q charge and point P? It is R minus A. So you can write here R minus A square. And what is the direction? The direction is in plus X. So you can take as unit vector of dipole moment P in plus. Okay. The next one, E at P due to minus Q charge will be E of minus Q is equal to KQ over the separation from minus Q charge and point P is R plus A square, and the direction is in minus of X direction. So it will be minus of unit vector of P. Are you clear till here?
Yes.
All of you understanding till here or not?
Yes, sir.
Okay. Now, what will be the net charge? Sorry, what will be the net field at point P? So, the net field at P will be E is equal to E of plus Q plus E of minus Q. Are you clear? We are going to add them vectorially. Okay. What is the value of E of plus Q? It is K Q over R minus A square of unit vector P plus KQ over R plus A square of unit vector of minus P. Okay. Then when you multiply this minus sign to this plus sign, you got finally KQ over R minus A square minus KQ over R plus A square, okay, of unit vector P. Okay. Now you can solve it by taking K and Q as common. You have in bracket R minus A square minus 1 over R plus A square. Are you clear or not? r plus a square. Okay, which is equal to k q. Sorry, this is also a unit vector of p. Now, after taking LCM, what you got in LCM? R minus a square into r plus a square as LCM, and you got r plus a square minus of r minus a square. Okay, of unit vector of p. Note it down, please. Note it down, please, till here. All of you have noted it or not?
Yes, sir.
Hello.
No, sir. Wait.
Okay, please write down first.
No, sir. Sir, done.
Yeah, okay. Once again, I am going to write this point. Sorry, this step again. On the next page, we have right now E is equal to K Q P R plus A square minus R minus A square over R plus A square into R minus A square. Okay. And now expand these two terms first. Okay. After expanding these two terms, we get r square a square plus 2ar minus r square a square minus 2ar, right? Over r plus a square r minus a square. And now multiply this minus sign into the bracket values kq into p vector r square a square plus 2ar minus r square a square plus 2ar over r plus a square r minus a square. R square and a square will cancel with r square a square because plus r square minus r square is cancelling here, and a plus a square and minus a square are cancelling. And now what we get? We get kq into p vector 2ar. Look at here, 2ar and 2ar will be 4ar. Are you understand it or not? Hello? All of you are understanding or not?
Yes, sir.
Okay. And r plus a square, r minus a square will be r square minus a square of whole square. Okay. Are you clear? Now we are going to arrange these terms first. How can we arrange them? K, Q, P. 4ar can be written as 2a into 2r. Are you understanding or not? It is possible. Is it possible or not? 4ar is 2ar into 2r. Hello?
Yes.
Yeah. So please write down here 1 second. 2a into 2r over r square minus a square of whole square. Now again, we are going to arrange them. K, we have taken K. Okay. Q into 2a. Look at here. Q and 2a. What we have right now? P vector and 2r over r square minus a square. Any issue in this step? Is there any issue in this step? We have arranged only the given values, given terms. Any issue?
No.
Okay, 1 second. Then we got K. What is Q into 2A? You have already know vector of P is equal to Q into 2L. You can write at the separation, in terms of L or 2A or 2X. Okay. So we can write here K into P. Okay. This is your P vector, which is electric dipole moment, into unit vector of P into 2R over R square minus A square whole square. Okay. This is your equation of electric field. 1 second. Okay. The another step. What is the unit vector of P? Unit vector of P will be vector of P over mod of vector P. Are you clear? Or we can also write unit vector of P into P is equal to vector of P. Are you understand it? Hello? One second.
Yes, sir.
Yes, sir.
Are you understand it or not? It is in magnitude, not in vector terms, which is given here. One second. This is your P, and this is your P, unit vector of P. So what is the vector P and magnitude of P? Look at here. This is the same value. This is the same value or not? Then we can write K vector of P into 2R over R square minus A square whole square. Okay. This is your equation. But in this equation, the one of the most important point to understand here, the separation is R square minus A square. Are you clear? To understand this problem, look at this page. The separation is R square minus A square whole square. Whereas we have already know the separation between these two dipole is infinitesimally small. I mean very, very small. If the separation between these two charges are very small, this means 2A will also be very small. Am I right or not? 2A also be very small as compared to the R, causing which we can neglect the value of 2A. Are you understand? Hello? Hello? All of you are understanding or not?
Yes, sir. Understand.
Okay. Why? What is the reason here? Because from the definition of the electric dipole, we have already studied here. It is the assembling of two equal and opposite charges separated by a small distance. Are you looking or not? You can also write here very small distance also. Are you understand or not? Causing which we are, okay, we can consider here the separation between these two dipoles are very, very small as compared to the R. Are you clear? So we can write here, one second, we can write here for ideal dipole. You can consider for ideal dipole, okay, the value of A is very, very small as compared to R. So R square minus A square will be nearly R square. And finally, we got E is equal to 2 K P over R cube. Note it down, please. Note it down, please. Note it down fast, please. All of you noted now?
Yes, sir.
Okay. Now we have the equation of this. Okay. This is your equation of electric field due to dipole on axial line. And now, what will be the direction of the electric field? I mean the electric field dipole. Dipole field, I mean. Let's see here. Please note down. Direction of electric field. Direction of electric field is same as that of P vector, I mean electric dipole moment. Suppose that you have suppose that you have a dipole like this and you want to calculate the direction of this dipole at another point P. This is your charge of minus Q and this one is the charge of plus Q. Okay. Then we want to calculate the position, direction of the field at this point P. Okay. And in another case, we are taking again the same dipole, but in opposite way. This is your now plus Q charge, and this is your minus Q charge. And this one is your point P. Okay. And now, can you tell me what will be the direction of the dipole in the first case? At point P, we have already known the direction of the dipole always be from negative to positive. Negative to positive charge, I mean always be in this direction. So the direction of the field also be in the same as that of the field. Look at here. This is along this direction. Okay. Note it down. And for the case 2, the direction of the dipole will be along the minus x, you can also say. So the direction will be in this direction at point P. You can note it. You can note down, please. Okay. This is the direction of the dipole.
Done, sir.
Note it down, please, all of you. Can we move on?
Yes, sir.
Hello.
Yes.
Can we
Done,
move
sir.
on?
Done, sir. Yes, sir. Done, sir.
Okay. Next heading is electric field. Electric field on equatorial line of dipole. Electric field on equatorial line of dipole. Okay. This is your next heading. And now let's draw the diagram first. second. These are two charges, minus Q and plus Q. And at equatorial position, we are taking a point P here. Okay. Now first join all of the vertices from point P. Okay. The separation between, one second. The separation between the two charges are 2A. Let's take as 2A. If it is 2A, then this separation will be A. And the another separation will also be A. Okay. And the distance from the line to the point P is, you can take as R. Then what will be the value of diagonal? It will be under root of R square plus A square according to the Pythagorean theorem. And this also be root of R square plus A square. Okay. And now we are going to draw the direction of the electric field at point P due to the plus Q charge. We have already know due to the plus Q charge, the direction will be always away from the charge. It will be always away from the charge. And now, due to the minus of Q, it will be towards the charge. Are you understand it?
Yes.
Yeah. If you draw a coordinate frame at, okay, with the reference of point P, then you got it like this. Hence, we can say here, the angle made by this of plus charge is theta. Then the perpendicular value will be E sine theta. I mean E plus sine theta you can consider. And on horizontal axis, it will be E plus cos theta. Just similarly, for the for the field of negative charge, this axis will be it is also making theta angle from the horizontal. It also be E of minus cos theta. And this axis will be E of minus sine theta. Are you understand it about the component or not? Hello?
Yes, sir. Understand.
Yeah. Note it down first, then we will try to solve it. Note it down fast. Can we move on?
Yes, sir.
Okay. Now, from diagram, you can look at R1. We can take it like R1 and this is your R2. R1 and R2 both are root of R square plus A square. Okay. Then can you tell me, try to understand here, the magnitude of both charges are same. Are you clear or not? Magnitude of both charges are same, but opposite in nature. Are you clear? And separation from both charges from point P is also same. Are you clear or not?
Yes.
If all of the things are same, then we can say that the electric field due to the both charges in magnitude also be same. I mean E of plus and E of minus will be K Q over R square plus A square. Okay. Sorry, just 1 second. 1 second. R square plus A square root of. This is your value in the root whole square. Are you clear? This is your value of R. Understand it or not? Finally, we got, after squaring this root, we get R square plus A square. Okay. Now, what will be the net field at point P? The net field on equatorial line. Net field on equatorial line will be, first of all, we will calculate the net field along x-axis, I mean along this axis, and then we will calculate the field along y-axis, and finally we will add them to calculate the net field. Okay. So what will be the field along y-axis? Ey is equal to E plus minus, sorry, E plus of E minus. E plus is your, you can look at here, E plus sine theta due to E, okay, due to the E minus, this is your E minus sine theta. Are you clear? E plus and E minus are same in magnitude. So we can write E sine theta plus E sine theta, which is, sorry, E sine theta, 1 second, 1 second. Both are in opposite direction. So the sign will be negative between these two. Okay. E sine theta minus E sine theta, which is equal to the 0. This is your electric field along y-axis. And now the field along x-axis will be Ex is equal to, can you tell me what will be the Ex? You can look at here, both are E plus cos theta and E minus cos theta. Both are in the same direction. So we can add them together. E plus cos theta plus E minus cos theta. Okay. And we have already know the magnitude of E plus and E minus are same. So we can write 2E cos theta. Okay. What is the value of E? Anyone? The value of E is this value. This is the value of E. You can put it here, KQ over R square plus A square. Okay. Into, what is the cos theta? Cos theta is base upon hypotenuse. What is the value of base? Your base is A. Hypotenuse is R square plus A square root. You can write here A over root of R square plus A square. Note it down till here first. Okay. Then we will move. Can we move on? Hello?
Yes,
Hello?
sir.
Done, sir.
All of you have noted it or not? Hello?
Yes, sir.
Okay. Now I am going to write again this equation. Okay. Or no, let's understand. Okay. I'm removing this part. What is this equation? Let's see here. See here. This is the value of 2 kq over r square plus a square into a over root of r square plus a square. We can also write root of r square plus a square as r square plus a square power 1 over 2. Can we write or not? So it will be 2kq into a. 1 second. Not 2kq. Q into 2a. Okay. K over r square plus a square of the power 3 by 2. Finally, we got k. Q into 2a is p over r square plus a square power 3 over 2. This is your value of x. Okay. Then what will be the net value or net field at point P? What will be the net field? Net field on equatorial line. Net field on equatorial line will be E net is equal to Ex plus Ey. What is the value of Ex which we have calculated here? It is your Kp over r square plus a square of power 3 over 2 plus Ey is 0. Okay. Finally, the net field at P is Kp over r square plus a square power 3 over 2. This is the net field at point P. All right. Okay. Now, for ideal dipole approximation, you can also write if we take ideal dipole approximation, then we have already know A is very less than R. So R square plus A square we can write as R square only. Okay. And now when you put this value in the equation, you got E net is equal to Kp over R square of the power 3 over 2. Finally, 2 is cancelled with 2. You get E net is equal to Kp over R cube. Okay. Where the value of K is 1 over 4 pi epsilon naught. You can also write. Okay. Note it down, please. Clear? Note it down fast. All of you have any other class? Hello?
No, sir.
All of you have any other class after this?
No, sir.
No.
Note it down, please. All of you have noted it or not?
Yes, sir.
Okay. Also write down the direction of E. Direction of E is opposite to that of dipole moment. Okay, note it down, please. Okay, now we are going to over this class today, and we will meet in our next class. All right.
Okay, sir.
Okay.
Thank you, sir.
Can we over now?